Okay, let's look at how to calculate the atomic mass. This is the problem on slide 25. I wanted to point out that when you see a notation like this, where you have the name of the element, dash, and then a number, typically what follows the number is the atomic mass for that element. And in this case, all three isotopes have slightly different mass numbers. And as you can see, magnesium 24, that is, its mass is about 23.99, 24. Magnesium 25, about 25, and magnesium 26, about 26. And I already went ahead and converted the percent abundances that were given in percentage, divided them by 100 to convert them just to regular numbers, because we don't want to use these when we're doing the calculations. We have to convert them to regular numbers. So let's go ahead and figure out how to calculate the atomic mass of magnesium. We do this by taking the mass of my first isotope, 23.99, and multiply it by its abundance, but not the percent, just the regular number. So 0.7870 plus, and I'm going to just stack them up here, the mass of my second isotope, which is 24.99, multiplied by its abundance, once again, not as a percentage, plus I have the mass of my third isotope, 25.98, multiplied by its abundance, but convert the percent to a regular number by dividing by 100. Okay. And then if I had other isotopes, I would just list them, continue doing the same thing until I ran out of the isotopes. Now I need to do all three products. So if you do this multiplication here, you should get about 18.88 plus my second product here is 2.531 plus the third product, 2.901 or 02. And if you add all of this together, you should get 24.31, which, if you look in the periodic table, is the atomic mass for magnesium. If you get something that is wildly off, that means you've done something wrong here. You've calculated something wrong. In the periodic table, that is how the atomic masses those numbers that are found underneath each symbol of the elements, that this is how it's calculated by doing exactly what we're doing. So if you get something that is completely wrong, then you've done something in your calculations. This is not, once again, notwithstanding or not taking into account little rounding errors or differences from just rounding. But if you have 20, for example, or 22, so a kind of a large error, that means that you've done something wrong in your calculation. So go back and double check your math. Okay, I am going to erase this, and then we're going to be moving on to the next slide.